All right, section 1-2 starts on page 12 if you guys have your books out. But what section 1-2 is going to do is I'm going to give you a equation and I'm going to give you the transformation and I want you to write the new equation based off of that. So as far as graphing wise goes, you probably won't have graphing as much today as you will or as you did on the first one. So what they have there for you is they give you this function, f of x equals 2x plus 1, and they ask you to, from there, write a new one that was translated 3 units down. Okay? So the 2x plus 1 is the original graph, and down 3 is the new one. So when you say down 3, does that get added or subtracted or multiplied first of all? Subtracted. Inside a grouping symbol or outside the grouping symbol? Outside. Why is it outside? Because we're going up or down. So when you're writing a new one for this particular graph, I'm going to take the original one and I'm going to subtract 3 to it. Now notice all I did was I put it in parentheses just to make sure that you had it on there. But realistically, if you're capable enough, if you took 1 and subtracted 3 from it, you would get the final answer. What's 1 minus 3? Negative 2. So my new one is 2x minus 2. That would be my answer for that new function. Again, I'm going to give you some transformations, and I want you to create the new one. That's what's going to happen. So for that particular thing, when it says up or down, you're going to add the number to the outside. If it says left or right, we're going to add it inside a grouping symbol. If it said vertically stretching it or shrinking it, then you're going to multiply it to the outside. If it says reflection, you're going to put a negative either on the inside or outside. That's what's going to happen. They're going to give you the parent, and then they're going to go from there. Let's give you a different family. Okay, what family? Absolute value. Good. This first one, we'll go reflected over x-axis. If I'm going to reflect it over the x-axis, which way or what do I put? Let's start that over. If I'm going to reflect it, what do I put first? A negative. Where? Outside the grouping symbol. Why? Because it was x-axis. Right? And we're reflecting it. So my new one, minus x plus 3 plus 1. And that's it. Now, obviously, I can make some that have multiple. The first two that I gave you just had one shifting or one stretching or whatever it was, or one reflection. I did not do a combination of them. Can we do ones that have combos? Can we do more than one at a time? Absolutely. So if I have the same parent, and this time we're going to go a vertical stretch by 2, up 7, right 5. What's the only thing I didn't give you that one of the types of transformations? I gave you a stretch, I gave you up, I gave you a down, or a left, or a right. What's the one I didn't give you for this one? Reflection. That's the only one I didn't put on here. So this would be an example of something that has 3 different pieces, or 3 different types. So let's start with the first one. Vertical stretch by 2. Anytime you see the word stretch or shrink, you should be doing what operation? Multiply. Right. Inside or outside? Outside. We haven't even talked about multiplying inside yet. So So for this particular thing, we're going to multiply outside. What about up 7? What do I do? Add. Where, Alexis?
Inside the grouping symbol?
For up.
Oh, outside?
Outside the grouping symbol. So what I'm going to do is, you see there was a 1 there? Add 7 to that. What's 1 plus 7? 8. And the 2 was out there. Why did I put the 2 outside again? I multiplied by 2. You guys already said that. I just wanted to double check. Right 5. When I go to the right, do you add or subtract the number? Good. What's 3 minus 5? 2. Not quite. -2. Awesome. Good job. That's one that has 3. The only thing I did not put in there is I did not put a reflection in there. The only thing that would have changed, honestly, is if I had a reflection over the x-axis like we had the first one, I would have put a negative in front of the 2. Or if I had a reflection over the y-axis, I would have put a negative in front of the x on the inside. What do you guys think of this? A little bit better?
Yeah.
As you get to see more of this stuff, you guys will become more comfortable with it too. Okay, some of that transformation stuff, I don't know that you've ever seen that before. So that's why it looked foreign to you guys right away, like you were doing Chinese or something. You were doing a language, and math is a language, but it's not Chinese. Okay? Although they had some parts to this too. All right, what do you guys think of that so far? So if you look on page 16, that's where the first ones are. It says for the directions, in exercises 3 through 8, write a function g whose graph represents the indicated transformation of the graph. Use a graphing calculator to check your answer. And hopefully by the end of the week, we should be, almost all of us having, I think, how many of you guys don't have one right now? We have 1, 2. So that's way better than it was last week. So we're getting there. Okay, so by the end of the week, we're going to start, or maybe even in the next couple days, I'll start going through how to use your graphing calculator a little bit. Some of you guys have used them before, some of you haven't. I will teach you guys how to, all right? But as far as writing a function, that's the rule. This up there on the screen right now is an example of multi-parts. Some of these first ones might only have 1 part. The highest number that you can have is up to 4 different transformations that took place. This one was 3. A lot of them are only 1 or 2. Okay? Then after that, it says describe 2 different translations of the graph that result of f that result in the graph of g. So tell me what happened. What did they do differently? Then 11 through 16, write the function g whose graph represents the indicated transformation of the graph. Use the graphing calculator to check. Notice there's only 1 thing there. On 17 through 22, it says write the function of g whose graph represents the indicated transformation. And again, they're talking about vertical. And now, if you see 19 and 20, they talk about horizontal. You haven't seen horizontal yet. Where was the vertical stretch and shrink located at? Where did we stretch and shrink horizontally? Or vertically, I mean. On the y-axis, but in the picture or in the equation itself, where did we put the multiplication? For vertical. Say it louder, Vitaly, yeah. Outside. So if outside is vertical, where do you think horizontal is going to go? Inside. Okay? Good job. Horizontal stretch, shrink. Ooh, can't spell this morning. Or ever. Multiply inside the grouping symbol. Okay? Now, this is the important part that you're going to need to know. What is if I said the word reciprocal, what does reciprocal mean to you? Opposite? No. Opposite would be like the opposite of 5 is negative 5. A flipped fraction. Okay? Reciprocal means you take the fraction and you flip it over. All right? So that word we're going to see when we talk about horizontal stretching and shrinking. Okay? Now, it's going to be a stretch when A is between 0 and 1. And it's going to be a shrink when A is greater than 1. Now, thinking back to what we had last Thursday with your notes on stretch and shrink for vertical, they were flipped, were they not? The stretch was greater than 1. The shrink was in between 0 and 1. Now it's the opposite direction. When we said vertical stretch, or vertical shrink for that matter, we always said by whatever number it was, correct? So like on the last one that we wrote the equation for, we said vertical stretch by 2. Done. When you report these ones out, or when you see these ones like this, it's going to say something like this. If you had a function where it's on the inside of a grouping symbol, like that would be. Notice I'm multiplying, but it's inside the grouping symbol. First of all, how big is A? 3. So would this be a vertical stretch or shrink? Shrink. So when I write that one, this would be a horizontal, because it's inside. Shrink. Oh my, why can I not spell? By 1/3. Okay? Now, this is where, when you report it out, you write the reciprocal of whatever number you're multiplying by. So notice what I did there is I took the 3 and I wrote the reciprocal of 3. Is everybody okay with that? So what if it would have been 3/4? It would have been a horizontal stretch by 4/3. So when you report it, you flip it over. Okay? Tomorrow.
Is that both for stretch and shrink?
Yes. Both for stretch and shrink. As long as it's horizontal, whenever you report it, it's the reciprocal of whatever number was on the inside. Conversely enough, if I said it's a horizontal shrink by 1/3, then when you put it in, it better be multiplied by 3. Okay, so be very careful with that part. Then on 23 to 26, it says match the graph of the transformation with the correct equation shown. Explain your answer. So what they're doing there is they're giving you 4 different things, and they're asking you to match the one that the equation would be. Did it get shifted up? Did it get multiplied on the inside or outside? Then 27 to 32 says write the function that represents the indicated transformation. That's where they give you more than one thing. Like I gave you for that one where I had 3 different options. Then it's going to ask you to tell me what they did wrong. I want you to think about that one. Hopefully that won't be so bad where they think about what's happening. And then one more word type problem where it talks about suppose the sales decreased at twice the rate. How can you transform it? Okay. So again, kind of like that one I gave you for today's where it was that basketball shooting one where you just interpret what's going on. So you're going to be doing a lot of writing new formulas today. That's what's going to happen. Not a whole lot of graphing. Okay? So on page 16, to 18. We're 3 to 36. Multiples of 3. So again, just to kind of remind you, that's 3, 6, 9, 12. Alexis, you'll have to explain that to Hunter, okay?